now open the floor for any questions that you may have. Thank you very much.
Thank you, Amisab. It was very nice here. I'm really impressed.
Thank you, sir.
Okay, Mr. Omar Hayat, Mr. Omar Farooq, sorry, is there. Can you kindly, sir, join us and have any questions related to that, please? Omar Farooq, sir. Okay, probably Omar Farooq sahab is not with the mic. So anybody else can do the question, all right? Please go ahead.
Yeah, Irfan sahab, I have 2 questions. First question is regarding the gridding options. Can you dig a little deeper in the what improvements have you made in the gridding algorithm? Because previously in the GeoGraphix, it was very gross, not very stable. We could not narrow down the grid interval to like 25 by 25 meter. So how you improved the gridding, existing gridding algorithm performance, or have you added some more gridding algorithm? So,
no, sir. So yes. So for the grid size, so the algorithms are this. We haven't added any new algorithms, but for the grid size, we are working on that problem. That's a problem with a lot of people. As you guys start working with bigger and bigger data sets, you want finer bin sizes. So we are working on trying to make our application 64-bit. That's not quite available yet, but hopefully by the end of the year, that's going to be out. We're actively working on that, and that's going to help make that bin size much smaller, like you were saying. So even though we don't quite have it ready yet, that is something that we are working on and should be available soon.
Yeah. The second question is, can we define now the compaction trends in the depth conversion module?
Compaction trends?
Yes.
I'm sorry, I really don't know anything about that. Mumtaz, could you maybe help us out here?
I think as far as compaction trend is concerned, you can use the structural guided masking model. In basically, you can define the structure, and within that structure, basically, we embed the chronostratigraphic layer inside that. If we have option, if you use that, then we use add the layers inside that, and then all the interpolation is guided by those layers. So you can use that option. Probably we can set up another demo on that, and you can try that. I hope that will solve your problem.
Yeah, because there are certain options, like we talk about petrol V0 plus KZ. With that you can define compaction.
Yes, certainly. So the V0 KZ method, we already have that. So we don't build a velocity model using the V0 KZ method, but when you're doing your horizon depth conversions for your horizon surfaces, you can certainly use the V0 KZ method to see a cross plot, define your V0 value, get the K value from that, a best fit line, and use that information to convert your horizons, create the depth surface for that horizon. And like I mentioned, we have 3 component horizons. So we save your time picks, of course, that's the picks that you make on your seismic. And then when you do a velocity conversion for a horizon surface, you populate that velocity column. So we have like 3 columns for each horizon. The time column filled by your picks, the velocity column that we fill, you can fill it by a variety of different methods. We can do it from any velocity model that you create. It could be an external cube that's being used as a velocity model. It could be your horizon formation based model, your structurally interpolated model, your seismic velocity model calibrated with wells, or you can use the V0 KZ method, which again doesn't do a velocity model, but you can specify that for the horizon surface. It's going to compute those velocities using that method and sort of fill that column for the horizon. Once you have the time, you have the velocity, you can then get a depth for each horizon pick and fill up that depth column. So you can use that method for your depth conversion if that's what you're looking for.
Okay, thanks. And can we load multiple trajectories for the same well and plan the trajectory?
Yes,
for the
absolutely.
well?
Absolutely. So you can have this is what we call a proposed survey. So one well, the well gets one sort of trajectory, which is considered its actual trajectory, but you can have many different proposed surveys. where you can say, okay, I want to drill this well this way, or maybe I want to drill this well this way, kick off here, whatever your scenario may be. So you can have multiple proposed surveys in for the same well, but yes, so of course the drilled well will only have like one final deviation survey or just the vertical well. But yeah, you can have many different proposed surveys on there, as many as you want.
So can we do the trajectory planning?
Yes, we have full-fledged well planning tools that let you do that. You can even view your well trajectories in WellBase, I think, in 3D view. I'm not sure on that, but I think you can do that.
Previously in the depth conversion, we can only convert the maps to the depth, and even we could not show that on these sections.
Sorry,
so can
you say that again, please?
In previous versions of GeoGraphix which I use, we can only convert the maps, not the horizons and faults, to the depth domain. So can we, other than map, can we convert horizons and faults?
Absolutely, absolutely.
Yes,
everything. You can compute everything. You can take horizons, faults, geobodies, maps, attribute surfaces. You can convert everything to depth. And we also, like I mentioned, we also have a depth mode that does this on the fly within your interpretation as well. So if you just want to take a look at it and not really, see what it looks like in depth using your velocity models, it does that on the fly with just a click of the button. But if you want to use it as an input to another workflow, then yes, you can go ahead and convert individual horizons and faults and geobodies and all that stuff to depth from time to depth.
Previously, basically, we only have this option for horizon, but now you can use that for faults as well. You can convert fault through the active velocity model and export that data in the form of depth sticks. That is not available now.
Okay, and obviously we would be able to display our map horizon over the seismic for the QC purpose.
Yes. So I guess what you're trying to say is that draw your horizon on a map.
No, display the map grid on this seismic section.
Yeah. Yes, you can. So you can on your seismic. I'm sorry, I didn't understand that. On your seismic section, you want to display a grid on your seismic section?
Yes.
On your vertical seismic section.
Yeah, you can do that in 3D view. Basically, you can create the mapping grid for the horizon and then add that mapping grid in 3D scene. And you open the inline X-line section in that, and you will see the whole grid cutting through those sections. No, that is possible in 3D scene, new 3D scene. You can add the horizon grid in that 3D scene as a object, and you can see that over there.
Yeah, because that's the main QC of the generated map, that how much it matches the input data.
Yes, you can do that right now. And even that, we have a tool that you can convert that grid into horizon. So there is an option available that will convert the grid to the horizon automatically. And then once you will do that, then you will snap that and to that horizon up to your desired peak or trough or zero crossing. So that is available now.
Okay, so thank you very much. And somebody else has a question.
Okay, previously for time and depth interpretation, we have to in the size vision in one size vision project we can only do either time interpretation or depth interpretation. If we for other interpretation, if we have time and if we want to have the depth interpretation, we have to go and generate a new size vision interpretation. So what about this new release or any update? And can we do time and depth in the same window, or we have to shift again?
No, so when you create an interpretation, it has to be either a time domain interpretation or a depth interpretation. We can't combine the time and depth seismic together. But like I mentioned, the depth view kind of lets you use the velocity model and convert your time data, time seismic, into depth seismic on the fly. So it's kind of like working in a virtual depth domain where your everything, all your data, your seismic, your horizons, faults, geobodies, everything is in depth already. But as far as taking a time seismic file and a time depth file, physical files, and putting them in the same interpretation, you can't do that. You have to have two separate interpretations for it.
It's same. We have two size region interpretations. We
Yes.
have two data sets.
Yes, if you have a time data set and a depth data set, you're gonna have to do it.
Then it's little bit. I mean, it's not. You can say it's not an easy to integrate. I mean, most of the software we have both remain in the same window. We just have to change the two-way time to TVD, and the whole data is being converted to the other domain if we have the velocity model.
Excuse me, we also doing that. Basically, you will create the time mode interpretation, and you add everything over there. You build the velocity model, and then we add a mode for that. That is virtual depth mode. When you will be in that mode, everything that is in time will be converted into depth on the fly. So basically, that will emulate the scene that same time interpretation behave on depth as well.
But you know, if I have 5 to 10 velocity model and I just want to compare the difference of the, I just want to see what is the difference of the depth conversion of these 6 to 7 velocity models.
Yeah, you can. So this option that Mumtaz is talking about, and I've been mentioning, that applies to the 3D scene. So you can open 5 different 3D scenes at the same location, convert each 3D scene to depth using different velocity models, and just compare them.
Okay, so if I have 5 to 6 depth conversion surfaces, can I do the analysis like the standard deviation and the depth error?
Sorry, we don't have support for that. No.
Okay. And similarly, what you have about the spectral decomposition?
Well, the GVERSE attributes application, the on-the-fly attribute generation application, does full-fledged spectral decomposition, does it on the fly, so you can look at the frequency breakdown on your seismic in terms of your amplitude, your phase, or a combination of the two seismic. It uses a proprietary algorithm that we call CAPS. And it's basically an algorithm that we came up with. The papers are out there, and I can send them to you if you want. It basically uses a variable time window, so it takes because one of the biggest issues in spectral decomposition is deciding the size of the window. Because if you go too small, you add noise to it. If you go too big, you lose the you lose the local trend. So what we do is we compute we take that window size out of the equation by using different sizes of windows and combining all that information together. And that's what the continuous amplitude phase spectrum method will do for you. So using that CAPS method, we compute those spectrally decomposed volumes. GVERSE attributes lets you preview them, so you can see what your 4 Hertz, 8 Hertz, 10 Hertz, 12 Hertz volumes look like, what that data looks like in terms of inlines, cross lines, time slices. And but if you want to use them in other workflows, you can generate those amplitude and phase volumes as well for spectral decomposition.
What algorithm when we use? Generally, software has either the shortwave or the full wave spectral decomposition, or the better they have the integration of the both. What do you have?
Basically, we have something that is in between the continuous wavelength transform and matching pursuit window. We have our proprietary that is combination of both. So it is much superior than the STFT and standard FFT. So it basically, as Hamid mentioned, we circumvent the Heisenberg uncertainty principle. Basically, if you keep time window short or localize the signal in time, then the frequency band will be not good. So either you can get the resolution in time or in the frequency. But in our algorithm, we basically provide the multi-resolution in time as well as frequency. We keep short time window and try to come up with the high resolution. So I'll send you the detail in a paper. We have a patent algorithm. I'll send it to you.
Yes, that will be good. That will be. The better they are doing the same kind of thing, but definitely if you share, then we will be in better.
Yeah. I have a patent paper in which all comparison with the other industry standard is available over there. So you can see that and compare the result.
Thank you. Okay, one more thing. Can we generate the flattened volume?
Yes, absolutely.
Okay.
So for flattening as well, same thing. You can do it on the fly for the entire scene, or you can do it at sections, and export a volume for that as well.
No, I mean, if I do some interpretation on the flattened volume and, and I want to see what I just want to convert onto my original volume. So is it possible?
Yes. So you can do your interpretation of flattened volumes. I didn't get the second part of your question.
I mean, if I have flattened volume, I mean, if I created a flattened volume and do some interpretation, and then I need to see what is my interpretation look like on original volume, which is not flattened. So can I do this?
Well, the way we do it is that when you do your when you flatten your scene, the 3D scene or the seismic section, it flattens on the fly. You do your interpretation on it, so you don't have to create a volume just to do your interpretation. On the flattened scene, you can interpret on the fly and then unflatten, flatten as you want to see what that interpretation is looking like.
Mean, by
so you don't have to create a volume and then go back to the original volume.
I mean, you can see that you are saying that by unflattening my whole interpretation of art, that will be goes to unflatten.
Yes. Yes. So for example, if you have a seismic inline open, you flatten it to horizon A, make your picks for horizon B, unflatten, and it's going to show you what the horizon B looks like. Unflatten, you can flatten it again on horizon B if you want. Same thing for the 3D scene. When you flatten it on the horizon A, for example, it's going to take the entire scene, the 3D scene with everything in it, and it's going to flatten that to horizon A. So you can see clearly in a 3D sense what's happening, when you flatten a stratigraphic surface.
And other question, what kind of editing we can do on the surface? I mean, if we have a surface, so I want to do some editing, what kind of editing you have? Because in Battle we have full-fledged mathematics available, we can do anything with that. And what kind of editing here we have?
For your surface, mathematical calculation, like I said, we have the 3D horizon calculator that lets you build your own, sort of equation, what you want to do with combine different horizons together, apply attributes and all that stuff. What do you exactly mean when you say editing?
I will ask again. I mean, if I have a surface and I just want to, you can say that the smooth some part of the surface.
Yes. I get it now. I get it now. So we have a bunch of horizon operations. We call them horizon operations. So what you're calling a surface, I think Petrel uses the word surface for the horizon. That's why I was a little confused. So we call them horizon operations. You can snap your horizon to take the entire horizon and just shift the event that you've picked on. So if you want to snap it to a trough above or below, or offset it, to a certain thing, you can do that. You can take the entire thing and you can snap it up and down to another event. You can smoothen it, of course. You can take the horizon picks and you can smoothen that. You can do dip and azimuth calculations. You can merge different horizons. There's something else that I'm missing.
Okay, I mean you have.
Yeah, okay. we have a whole suite of them. We call them horizon operations.
Okay, and if we have, can I have surfaces and I want to display, I have depth surfaces, and I just want to display the value of that depth surfaces against some of my well tops. Is it possible?
Yes, if you have a depth surface and you want to, you'll have to use the zone manager for that. So you can populate your zone and then just display that data on your wells.
No, I just want to display the value of my surfaces against the well tops. Because sometimes we have the mismatch between our
yes, certainly you can do that. So what you can do that is you can add your wells to your 3D scene, post your formation tops along those wells, add your surface to the scene as well, and you're going to see very clearly what's happening. You can do that on the 2D section also. So if you have wells along an arb line drawn with formation tops displayed on there, add your horizon surface and it's going to show you the differences. You can right click on any horizon and it's going to give you using the velocity model, it's also going to give you in time interpretation, it's going to give you a converted value for the depth. So you can actually also have like a quantitative estimate of the difference between the formation top and that horizon, even if it's time. So it doesn't have to be depth. It can be also in time. We'll use the velocity model to do the conversion.
If I have 2D, sorry, if I have two 3D survey and I just want to merge them into a big survey, so can I do this?
You have two 3D surveys and you want to merge them into one big survey. I think you'll have to do that outside of GeoGraphix. You can create a take the SegY and merge them together and then load that single SegY. I don't think we can take surveys and merge them within the GVERSE Geophysics application. Mumtaz, is there anything we can do with GVERSE Geophysics to do that?
Basically, you have no. They have no.
They have to use SegY merging tools outside.
Yeah. They have to export that in SegY. First data, if they have two separate SegY for each survey, yes, we have that tool, but they have to use that.
I mean, that is outside the this GeoVerse.
Yeah, so we store our data in 3DX format. That's our brick format that I mentioned. So what you'll have to do is you'll have to export that to your to get two SegY files and then merge the SegY files and load that data back in. So there is no native capability to take two surveys and just say survey 1, survey 2 merge. So we can't do that. No.
And one thing about the depth velocity modeling. I mean, in velocity modeling, we can use only horizon, or can we use the fault? Because sometimes we have thrust.
You can use the fault as well. So the way we do that is that we, if you have fault polygons computed for your faults and horizon intersections, you can tell your velocity model to include those fault polygons or take care of those fault polygons to exclude those areas or from your velocity modeling. So you can incorporate fault information into your velocity models for sure.
By doing that, we have to use the multi-Z values. I mean,
no. Yeah, so you don't need to use your multi-Z values for this particular purpose. If you want, of course you can, but if you create your fault polygons, they can be for normal faults as well, and you can just sort of tell the model builder that you want to include that fault information into your velocity model.
But with fault polygon, the purpose will not serve, because if you have thrust part and you have the repetition of the section, okay. So if only the fault polygon, so he don't know about the where.
Yes. So the only way we can include fault information.
Okay, one more thing that sometimes we have very close horizons in our velocity model, and we want to merge them. Means suppose I have a thickness variation, time thickness variation in my horizons. At some places it gets very closer to my upper horizon. Two horizons are getting very close. So in better we have option that we can in that area we can merge them together. Can we do here also?
No. So you can either exclude the entire horizon or include it. We can't take, what I'm understanding is that you're saying that in a certain sort of region, you're going to sort of merge the two horizons into one, but for other areas, you're going to leave them as we can't do that.
I agree. In better, we have option that if horizons, we can define a value. If two horizons, your two surfaces, they are coming close. If I assign that if the two horizons are coming 10 meter close to each other, 10 meter or smaller, so he will consider them as a one. Okay, by doing this, I can control the problem, the problematic area.
That's a very smart way to do it, I guess. We don't have an option like that, but that's I really like that. I think that's a very smart way to do it. So I'll make a note of it, and hopefully we can include it in one of our updates. But right now we don't have that functionality.
And what about the during the velocity model when I apply the Veritops for correction? Okay, so is it possible that we can display the correction maps or the uncorrected and corrected, the comparison of the uncorrected and corrected, and the residual effects?
The residual maps is something that we're working on. We don't have that capability yet.
Excuse me, what about the geologist? Somebody can come out and have a few questions. Mudassar Saab, are you there?
जी हूँ, असल में ज़्यादातर इसमें जो डिस्कशन हुई है मोस्टली इसी से रिलेटेड है। हमारा भी पार्ट ऐसा में था नहीं जो डिटेल्स जिसके ऊपर आप बात कर सकें इसमें। तो जो
बिल्कुल सर, that's a fair point, sir. The plan was because if I included a geological aspect to it as well, this would have lasted another hour or so, and already I am sure I bored people out of their minds. So the plan was, and Sohail can elaborate on it, was to do a geophysics-centric sort of presentation first, and then hopefully in the coming days set up another session for our geologic tools to show what we can do there, because we have made a lot of progress in that area as well. So maybe Sohail can shed a little light on that. Are we planning a geology session as well, Sohail?
Yes, we can plan the session during next week or week after next week, based on the feedback from PPL. I will coordinate with the Chief Sub and we'll see.
Yeah, I would, from this forum, I would suggest all the geologists in particular to please share with me and consult yourselves even the real problems we are having, the whatever handicaps you are feeling in the software. Because you see, there is a fair chance of collaboration between LMKR and us, and I hope as a Pakistani company they will entertain us, and as they had mentioned in their presentation, that they have got developers who are working on the latest, let's say, software, which I believe is the Python, and they are also working in the fields of machine learning as well as artificial intelligence. I'm sure our feedback will certainly help us in particular to make our, let's say, whatever requirement is. So I hope they will also consider us, and with our due collaboration, we will come up with a solution.
Sorry, one thing, can I ask one more question?
Yeah, please.
Okay. Sorry, I missed that the probably Vakar he was discussing. In velocity model, either we have option V0 KZ.
Not for the velocity model. You cannot build a velocity model using the V0 KZ option, but you can when you're converting horizon surfaces. So we have different ways to convert your horizons to depth. You can use either the velocity model, or we have 2 or 3 different methods that apply only when you're converting horizon surfaces from time to depth. So you can use the V0 KZ method to convert your time surface, take your time surface, and get your velocities for that time surface using the V0 KZ method.
One more thing, that can we use some kind of filtering? Means suppose I have 20 well, I want to use the 10 well only. So Petal we in Petal if we want to do that, I just need to create one filter and use that filter during my velocity model. Yep. Are there any other? So can we do this?
You can do that. We can do this. It's not as streamlined as you're mentioning it is for Petrel. That's not just a click of one, but what you'll have to do is you'll have to just include those wells in your interpretation, build your velocity model, and then bring the rest of your wells in. So we have filters, so you can say, okay, I just want this filter of wells in my interpretation at this moment, build your velocity model, and then bring in the rest of your wells again, add the rest of the wells to your interpretation. So it's going to be a 2-step process, not just a single-step process.
And one more thing, that how we loaded the corridor stack. I have well data and I have the VSP data and I have the corridor stack, the VSP stacks. So how we loaded it into our well data? Is it same like
do you want to view VSP data along the well?
I have corridor stack.
Actually, breaking up corridor stacks. Yeah. Okay. So so that's what I'm asking. You're trying to view those along your well bore.
Yeah, Kamran Sahab is there. Kamran Sahab?
Okay, sorry.
Yeah,
some problem in your voice. Please. Okay, and my question was that if I have loaded the corridor stack, can we apply some kind of a shift on that stack? Static shift.
For your VSP, no, sorry, we don't Like I said, you cannot display your, or add VSP data to your well data. We don't support that.
If we can create the synthetic, so why not corridor stack? We are already displaying the seismic. Synthetic is just like a seismic. So if we can display the synthetic, so why not we
because the synthetic trace we create ourselves, right?
Sir, can you hear me? Basically, you can bring that VSP data as a 2D file. So if you bring that as a 2D file and then create synthetic and use that data out of that 2D file, then that is possible. But if that data should be imported as a 2D line. So this is the limitation. So right now we can bring data from the VSP data as a form of 2D line. So if we do that, then we can have.
We used to do same when we were working on the geographic. So, but that's not a good way. Generally, we don't have any navigation in the corridor stack. So it's good if we have option to load it into our well directly. Anyway.
We can discuss about that, and we can extend that capability in our side. So we need some more detail on that. We need to understand that what exactly you want. I'll keep in touch with you and probably will do that. That's not a big deal. So we need.
No, you are right. Definitely, with the time, the things will develop, and then definitely you will do the same.
We are doing a lot of stuff. Basically, then we are building things incrementally. So this session is very good. We got a lot of invaluable input from you guys. You are the real user. So probably we'll take our notes and we'll keep in touch with you guys and come up with some new release plan around that, and we'll embed that stuff. So you can see that in the last couple of years we have done a lot of things, and I would suggest that you can do some evaluation on our software that will give you the real feeling that how good we are. So basically we have done, it is our understanding we have done a lot of things, and everything is developed from Islamabad. We developed everything from scratch, even 3D engine. Most of the petrol, even landmark are using third-party 3D visualization engine, but we developed that over here in Islamabad, and you can try at your side. So basically we need your support. If you will give your valuable input, then we'll develop more new stuff in collaboration with you guys, and this is support we need from you guys.
Definitely, we will, inshallah. Okay, thank you. If someone want to ask any other question.
Yeah, please. There were a few questions like porosity distribution. Can you tell us more about that?
Yes, so I tried to cover that in the. Sorry, Bamraj, go ahead, please.
Yeah, just go ahead and demonstrate about say a few words about predict 3D. That is the one way. The other way is just do the porosity evaluation at well location using the petrophysical analysis and then do gridding for that. So right now we have two ways. One is predict 3D and the other is just compute the porosity at well location and then do the gridding and just spread that data up to the whole extent. But Hamid, say a few words about predict 3D, how we do that.
Yeah, certainly. But before I get to the predict 3D option, for porosity distributions, I think if you look at it in the standard sense, and I tried to cover that in that integrated workflow that I was talking about. So, you know, the petrophysics module lets you analyze logs, and you can get porosity for your porosity logs and porosity for your zones, populate that into zone manager, and then create a porosity map, or what I think is the users are referring to when they say porosity distribution. Get a porosity map for your entire areas. You grid that from the petrophysical properties and get that porosity map. Once you have the porosity map, similarly, you can do it for other petrophysical parameters like water saturation. Then you can create thickness maps for your horizon or your reservoir interval from geophysics. Again, you can create a map for that, an attribute service for that, do an isochrone, score, whatever you want to do. And then combine all of that together using a formula, volumetric formula, to compute your volumetrics. So I try to cover that during the during the integrated workflow. I may not have articulated it as well as I would have liked, but that was the intent there. Predict 3D is our AI tool, again developed with the help of Lumina Geophysics. So what that does is it takes your log properties, so it takes logs at different well locations, and it tries to combine that with the seismic data. So so the input is your seismic data and your log curves. It then tries to figure out a relationship between that log property and the seismic. So it computes a bunch of attributes, does that internally. It tries to figure out the best way, and it's like a non-linear equation. So it does like a neural network analysis of it, and comes out with an equation with different weights assigned to different attributes, which it thinks can best predict that log property at each inline cross-section location for your seismic cube. Then it applies that equation to all your seismic traces and computes a porosity volume or a V-shell volume or any other log property volume to the entire cube. So that's all.
It also do the blind testing internally. Basically, it internally hide the few wells that you are using for the prediction. So it hides and then see the predicted result with the actual result and compute the error and try to minimize the error. Once the error will be minimized, then it finalize the weights and apply that weights up to the whole, and then show the result along one inline or arb line for the user, and user see that how the result good are. If he will be satisfied, then user will be able to apply that result, that weights up to the whole seismic volume, and after that you have the porosity cube up to the seismic extent, and then you can use that wherever you want.
Well, with that, I think it was once again, I will tell you, it was a very nice presentation. I'm really impressed.
Thank you, sir.
I thank all the attendees here who were shown their full concentration, and they were there. Unfortunately, we didn't cover much of the geological features, and I hope in our next meeting we will cover that. And
yes,
we will give you the particularly LMKR deserves our let's say hello, are you there?
Yes, definitely we're here, Sergi.
Yeah, sorry, sorry, somebody else. So what I mean is, you see, so Rashid Sahab, I am really thankful for that, to you in particular, and to all the participants who were there for attending and with full concentration. And there were, you see, few of our seasoned interpreters who were there. They questioned us, and particularly Naeem Sardar and Waqar. I am really thankful to them making this presentation success. Fortunately or unfortunately, you see, Tariq Sahab is also there, and Umar Farooq Sahab is also there, and few of our colleagues are on way Lahore to Karachi. So Amir Bhatti Sahab and Musharraf Sajjad, who are also our seasoned interpreters, unfortunately were not present in this presentation. I hope if it is possible, can you kindly somehow email us this webinar recording is there. If you can share that, kindly, if possible, to do that. So, Rashid sir.
Yes, definitely, Fasad. Thank you very much for all the users who participated in this. And we are open for any questions. If they have further questions, they can send us an email on that. We will share this recording with you, and we'll also schedule a second session for the geology. I would also like to add that we have deployed a license file there in PPL since last year, which has all the new features and the GVERSE modules. So I would request all users to use these applications, and feel free to share their feedback on these GVERSE modules.
Sohail, I will add one thing. Basically, most of the stuff we showed is the part of the new release that will be available in next month. So we'll upgrade that as well. So it would be great if they can start evaluation on that release. they can just try in the previous version, but in next month we will upgrade that with the new release.
Great.
Sounds
It
good.
was a request from me, excuse me, Sohail in particular, and rest of the attendees. It was a request from me if it is possible, if there is a support service sort of thing is available, particularly online one, so that you can see straight away answers all those, let's say, wherever the bottlenecks are. So I hope you can also arrange for that. Do you?
Ji, for online support, we are always available. We have 24/7 support desk available. But for the on-site, we will see after the COVID-19 situation will settle, then we will provide the on-site support as well.
Great. So I hope you see. Can you share us with the whatever the contacts are, so that I can share it with my all colleagues and.
Is it?
You see,
Cesar from our side will provide the details of the how to get the support from the support desk.
Exactly.
Great.
I would shortly email you detail for that.
Great. We have got, you see, a lot of youth with us, and these guys can, I am certainly sure that they can give their challenges to us, and we will resolve them. So that's a really a challenge for all of us. All right. So Tariq Hasni Sahab has joined us. I hope already we are 2-3 minutes late, but you see, he will give us the remarks we have. Tariq Hasni Sahab, kindly, can you attend us for?
Thank you. First, I'm really grateful for the LMKR for their presence, and they have taken this presentation for us. They prepared quite a lot of interest, and they have done a good job drawing a lot of attention, and that's quite attractive, in fact. I haven't seen the entire presentation, but I think most of our geoscientists they have really seen with interest and keenness. And the whole idea why the GeoGraphix presentation was planned is that initially we bought the GeoGraphix back in 2003 or something like that. At that time I was in PPL, so we have been using since then. Work has been probably introduced in GeoGraphix, which is brand new, and I'm not aware that how much updating GeoGraphix have been providing to our existing licenses. So anyway, that was an opportunity on which we think that GeoGraphix need to be looked again, whether is it at par with Petrel or the compatibility, how good the compatibility with Petrel is. And of course, in these circumstances, when the economics is the key factor controlling everything, if in future we will have to think about switching our few of the softwares and buying some new softwares on some relatively high standard and with the relatively less price, then probably we would have to look other softwares as well, including GeoGraphix. Of course, we would continue working with the Petrel. So I'm sure our geoscientists, PPL geoscientists, this session might have been very useful for them. I'm thankful for Jazeb because he has contacted me and I have asked him just to prepare a presentation, and Irfan Latif very kindly coordinated with the LMKR team. So by that I say thank you very much, and thank you all the geoscientists of PPL who have attended. I hope you would look all the aspects of the GeoGraphix unbiased. Most of you have been using Petrel for a long time, and you've been very familiar with the Petrel's workflow. But I know a few of you are still using GeoGraphix. So the difference between Petrel and GeoGraphix need to be evaluated and carefully assessed whether GeoGraphix makes any sense to be continue as a 1-hour interpretation software. By this, I thanks. Thank you.
Sounds good. Thank you very much.
With that, we close the. Thank you very much. And yeah, please go ahead, Sohail.
Jazakallah sir, thank you very much. Just
बहुत शुक्रिया सर आप तमाम अटेंडीज का, और अल्लाह मियाँ सबको खैरियत से रखे। जुमे का दिन है। अस्सलाम वालेकुम।
all right sir, so I will coordinate with you for the next session. Thank you very much for joining.
Allah Hafiz everybody. Thank you.
Allah Hafiz.